digitalized world, data has become enormously plenty. With the rise of digitalization came the bloom of data science. This field has become a significant one in today's world. Here we have Mrs. Tamilarasi Ganesan ma'am connecting us through virtual mode. Welcome you ma'am. Currently working as a professor in the Department of Information Technology, Al-Musannah College of Technology, located at Sultanate of Oman. She is a self-motivated faculty with 17 plus years of teaching experience in India and Oman. Published 2 international publications in different journals. Cisco Certified Network Associate Instructor for Networking and IoT courses. Not only that, but she has also contributed to the society by being an ambassador for Internet of Things in Smart City platform supported by the Research Council of Oman. She is a member of Technology Transfer Office funded by the Research Council of Oman. She's been a mentor for the funded projects in Research Council of Oman. Let us proceed with the event, ma'am.
A very warm good afternoon to one and all. I believe my audio is clear for the audience. The today's presentation topic is about the power of predictive analytics in a data science perspective. We know in this day-to-day world and the generation of the data that we are getting that much huge data, how we are going to play with the data has become a major point. So to deal with this data, we need to concentrate more on the data science perspective. Is it okay?
Okay.
Okay, fine. So let us discuss initially, before moving on to the predictive analytics, let us discuss about the basics of what is data science, why do we need to use this data science for the predictive analytics. We know data science is a multidisciplinary field which deals with many statistical and computational techniques, where we are using these techniques in statistics, mathematics, computer science, and different kind of domain expertise also required to solve the complex problems. So here, this data science plays a major role in business to make some decisions which could foresight in the future what we can do with this, or how we can proceed with the business, whether during the bottom line or to the top line, how the business can deal with the ideas that is extracted from data science. So here, it's a concept where analytics, machine learning algorithms, and different methods were used to make the actual phenomena with the data. So here, majorly, the different techniques that are involved are computer science, math and statistics, and the domain and the business knowledge. These are the major things that is involved in the data science. So why are we talking about data science? Because we know in this smart world, the growth of data has increased much more uncomparable times when we compare to the normal data growth rate. So when it was normal data growth, the data analysts were enough, and with that analytics, we were able to foresee some information. But now, because of this huge data growth, the only data analytics is not required, and we are moving to the data science because we need the scientists to identify the or extract the knowledge to reproduce it to a useful information that can be implemented in future. So if you want to predict something in the future, you need to move on to the data science. Here, what is this difference between the analyst and the data science? So analysts are the people who are mostly connected to the business administration. They know the concepts of the business and the exploratory data analysis. They do huge analysis only. So what does it mean by this analysis? It is they use the business administration and the data that is connected to the business, and they do analysis to extract what has happened in the past. So within the business or any other data, what has happened in the past, how it has executed, what is the flow of data, whether what are the ups and downs, so they can do, the analyst can do that only. When you move on to the scientists, data scientists, what they do is they do analysis. Also, they use machine learning and different kinds of advanced algorithms. You know, there are various kinds of machine learning algorithms available for the data science, and those algorithms were used in the exploratory data analysis, and they create a data product engineering. So with this analysis, not only the past, they can also foresee the future. That is, they can gain some knowledge that can be utilized in the future. That is why it's a combination of traditional research and a data engineer and the machine learning. So all these three things combined together, it gives us a useful and fruitful thing called data science. And when we are why we are using this data science, where we are using this data science. So moving on to that, initially we need to know what is predictive analysis. So predictive analysis, we know prediction, it means itself, we know that it is something what is going to happen. So predictive analysis is a powerful tool in data science that can help the business and different organizations in making their decisions based on their past, what has happened, and in the present, what is happening. So with the analysis of huge data set and by implementing different kind of machine learning algorithm, predictive analysis can be done and a pattern can be identified. That is the most important thing in predictive analysis. So a pattern can be identified, like how the flow of data goes, how the growth of the business goes. Either it's in the upper line or in a lower line, so that you can predict the future of the event that is going to happen. So it's this predictive analysis, especially, it's a process of statistics and machine learning with the historical data. But not only what has happened, we predict the future and the outcomes. It also involves in identifying the patterns and trends, how it moves with the informed decisions on predictive insights. So here in the predictive analysis, when we talk about the industrial view, majorly nowadays in each and every business administration, they started using this data science, especially for the predictive analysis. So here we can talk about finance, healthcare, marketing, manufacturing, and transportation. In finance, when we take how we are going to use in the finance, that is, you need to know the market trends, what kind of investments you can do. You can make decisions by using the predictive analysis. You can do stock market analysis and you can invest in the stock market, as well as in the healthcare, to identify how the disease development of the disease, outbreak of the disease, what if this disease comes, how the patient need to be treated based on the medical past record, what is going to happen for the in the future for the patient, everything can be analyzed. And in the marketing field, we know the behavior of the consumer, the need of the consumer, what are their preferences, what are their pattern of buying, and what is going to be in future for marketing. So each and everything we can analyze in the view of data science. So in the manufacturing field, whatever how the machineries operates, how it is used, each and everything we can analyze in the past. But using this predictive analysis in future, how these machines, how we need to schedule these machines for maintenance, how these machines may fall in a failure at a later stage. So everything can be analyzed. So you can improve the efficiency of the production by using this predictive analytics. So in the field of transportation also, we know nowadays we are using Google Maps, and here we go, and many different kind of maps to identify the tolls, traffic patterns, and what are the risky areas, what are the accidental zones. So everything we are getting, how we are getting, these are done through the predictive analysis and the Google Map, and the here we go, everything they are supporting us with the knowledge that is going to happen if you go in this road. For example, maybe it is very free, there is no toll, no traffic, nothing. Some other way route, if you choose, maybe it will identify and show you huge traffic, accident zone, anything it can show. So in transportation also, it is playing a major role, the predictive analysis. So now let us see how does this predictive analysis works. As I discussed already, the predictive analysis works by using the statistical method and the machine learning algorithms. So using this too, we are going to analyze the historical data and we will predict the future. But to do this, it's not just like that it is possible. We need to move on to multiple steps: data collection, then data preparation, model selection, model training, model evaluation, then prediction. At last stage is the prediction. So here, when we talk about data collection, how do we collect the data? You may think data is just there. I'm going to just use it and do some analysis, statistical analysis. I will get the result. No, that is not possible in the data science. You can do that, but if you do that, you will not get an accurate results. So the first step is to collect and organize the data. You need to get the data from the proper sources. It needs to be arranged, structured in the form of database or spreadsheet or whatever it is. And here in the data collection, you have two options. One is primary data collection, which we mostly use, and the second one is a secondary data collection, which is not so common, but at times we will use as well. So the primary data collection from where we'll get is from different interviews, observations, surveys and questionnaires, and focus groups like students, like the public, the youngsters, the old age, the focus groups, the data that we are getting from the focus groups, and the oral histories. It's not so clear, but based on the histories. And in the secondary data collection, we go through internet. So there are data wrapping, data binning, many things are available. So we can get it from the internet and also from the government archives. In India, we have a big government archive which is open source. Anybody can use as well, and some libraries. Once the data is collected, either in a structured format or in an unstructured format, we need to go for the preparation. So what is the structured and unstructured format is? The structured format could be, we can say it's properly aligned. You could see the data, it's in a table format like database, spreadsheet, like that. But this unstructured data, mostly it's like a image, it's like a audio, it's like a video, something which is not so organized. So now we will move on to the data preparation. So after collecting the data, you will be cleaning the data, you will be consolidating the data into a single file. Because before doing any process with the data, the data need to be cleaned and accurate and with good quality. How I will do cleaning and how I will find out the quality is I need to remove the duplicates. If there are any missing values in the data, I need to fill the data missing values, or I need to delete the missing rows. And if the data format is not correct, I need to fit the data into a correct format. What is that not correct format? Means, for example, value 10 you want to mention in the table. You have to mention the numeric value if all are numeric. Instead of that, if you mention the data as TEN10, then that could be a different format. It won't be suitable for analysis. So you have to clean that data also. So standardizing the format, proper enriching the data, removing the outliers. This is also very important. What is it? Outliers is the lower limit and the upper limit. For each data, we will have that limit, and we need to fit our data into that limit itself. And in this, more deeper into this data preparation, we have data discretization, data cleaning, that is, as I say, filling the missing values, duplicates everything, data integration, combining all the data into a single file, and data transformation, checking for the format of the data, and finally the data reduction. So these all steps involves in data preparation. Once the data is prepared, we will move on to the model selection. Because once the data is ready, here we need to use the machine learning algorithms to analyze the data depending upon the problem. What is your type of problem? What is the type of data you need to analyze? So for this, there are different model selections methods available. So when we see initially in this data collection from the different sources, when it is over, when the cleaning is done, the clean data set will be used for applying any of the algorithms. Then you will get a right model for evaluation. So here, this model selection, there are three things. One is random, trained or test split, either this way, or cross validation or bootstrap. You can use any of the model. And the key considerations in this model selection, what we need to look into and how I will choose this algorithm is, you need to first know nature of your data set. What kind of nature your data set? It's based on questionnaires, it's based on numbers, it's based on images, what kind? And columns collection, how many columns you have, and what are the details of the columns, and type of individual column. It's supposed to be a number or a text or a range, percentage, whatever it is, type of the individual columns, and the given problem statement. With this all data, what I need to get, what is the result I want to get. So if you know all this, then it will be very helpful for the model selection, so that you can choose any one of this, either random train set or cross validation or bootstrap method. So once the model selection is done, you will move on to the next stage called training the model. So here, using the selected algorithm on the historical data, it involves splitting the data into a trained set and a test set. Your entire, for example, 10,000 row of data is there. 75% of the data will be used as training set. 25% of the data will be used as test set. So it's all same data. Then why do we talk about training data and test data? That is, initially in a model, you will not test with completely the whole data. You will just use the 70 or 80% of the data to train and tune your algorithm such that it will give a result. So train and tune your models. This we do with cross-validation method. And at last, once everything is done, trained, and your model is tuned, you will at last use the test set. And this test set is unseen data it will not be visible. We will use it as unseen data to evaluate your model accuracy. So here, you should always split your data before doing anything else. Not the 100% data you should not use for training. So this is the best way to get reliable estimate, because if you want to improve your accuracy, train your model, then test your model. This is the one which we always follow in data science. Once you train your model, now you will move on to the model evaluation. So the trained algorithm need to be evaluated. How we evaluate? As I say, the training is done through train set and the evaluation is done through test set. To improve the accuracy and effectiveness, we need to use the test set. And here, this model evaluation ensures finally the model is performing well, and you will get such an accurate predictions based on this. It will ensure you. So the two methods are holdout and cross-validation in data science. So here, once the model evaluation is done, as I say, the holdout or cross-validation method, it has differences in applying the concepts. So the model evaluation holdout, how it works is, the test set is divided into three. One is for training, one is for validation, and other one is for testing. So the training set is used to build the model. Validation set of data is used to train the model, and the test unseen data is used to evaluate your model. So these are the three subsets in the holdout method. And in the cross-validation method, it's completely different from the holdout. And here, for the limited data, we will use this cross-validation. If you have very huge data, you will move on to the holdout. And if it is very limited data, we will move on to the cross-validation, where K-fold cross-validation is used to evaluate the model. What is this K-fold? That is, your data is divided into K subsets of equal size, either 5 or 10 or 3 or 6, anything. So it builds the model for each subset each time, one time, one time, one time. And finally, once it tests the model, build the model, it will leave the data set. The second one, then it leaves the data set. So it is called as leave one out model also, the cross-validation. Once this model evaluation is done and you are able to know the accuracy of your model, finally you will move on to the prediction. So finally, the model can be used to make predictions about future events or the outcomes based on the new data fed into the algorithm. You can make a proper decision upon how to drive the business, what you need to implement to improve your business. So here the main goal of developing this model, we need to get the accuracy in predicting the future, because if you go less in accuracy, then your prediction may not be correct in the future, it may go wrong. As we are concentrating this more into the business, so the predictive modeling is a very, very key concept, especially in the financial forecasting and marketing analysis. So here, by using this predictive model to analyze the large data set, we need to note down that the predictions are always not accurate, because various factors that affect predictions: quality, quantity of data. Because if you use less data set, small data set, your accuracy may not be good. And choice of algorithm, if you choose a different or wrong algorithm, your accuracy, your prediction may not be correct. And inherent randomness or uncertainty in data. The data keeps changing and it's not proper. So these all things affects the prediction as well. So when you go on to the final stage of prediction, you need to concentrate basically in the proper data. And with this prediction, what are the benefits of predictive analysis? The first one is improved decision making, because it helps the organizations to make a proactive decision that can positively impact their bottom line and increase the efficiency. So here, production or maintenance or whatever it is, based on the predictive analysis, more efficiently you can avoid the downtime. and reduces the risk as we foresee the organization will identify the potential risk initially and they will reduce it. And personalization, this also helps the companies or business to personalize their products based on the future need. And competitive advantage, that the predictive analysis can provide organization with a competitive advantage by identifying the emerging trends and the predicting customer behavior and the cost savings. So here the cost savings, the company can make a supply chain environment to reduce the inventory cost. So by leveraging the insights provided by the predictive analysis, organizations can make proactive decisions that positively impact their bottom line. So with these benefits, where are these predictive analysis used? How it is applicable is applications of predictive analysis. We talk about financial forecasting, so that the profit margins and the revenues and the risk, what is going to happen in the future, so you can make a strategic planning based on that. And customer segmentation, so you can, based on the future prediction, you can segment the customer for your product and you can do the marketing based on that. And the healthcare, you can easily identify the treatment plan, what you need to do for the patient in the future. And fraud detections, it identifies and helps the financial losses for the company, what is going to happen in the future. And supply chain optimization, it identifies and improves the inventory management, that how much it is required, how much production we need to make it at present to manage the future. And sales forecasting, the product which is required, more required in the public, either kind of product which you can choose and manufacture and you can sell it in the market. And equipment maintenance, and in the transport and logistics. So this predictive analysis can be applied in any industry. It's not, these are some of the examples only. It can be applied in any of the industry, wherever, if you are able to collect the data, analyze the data, and where predictive insights can help inform decision making process. So here, though there are so many positive things in predictive analysis also, still we have some challenges as well. So what are the challenges in predictive analysis is, first thing is data quality. Because if you want to do the predictive analysis, you need huge amount of high quality data. If you are using the poor quality data with missing values and missing errors, your accuracy will affect the prediction. And the second important challenge is data privacy and security. As we do predictive analysis, it involves most of the sensitive data from the companies, like personal information and the financial information. So if you are handling this very, very private data, then your security risk is very high. You need to follow proper protocol where you need to protect your data privacy and security. And model accuracy. The predictive models, as I say, depending upon the algorithm which you choose, your accuracy may differ. You need to try with different models so that you will get a proper accurate model. If you just use one model and you get some accuracy, you may not get it 100%. Any model will not give you 100% as of. But you can train your model in different ways to improve your accuracy. This is also one of the challenge. Just like that, you cannot use any algorithm. And interpredictability. That is, sometimes the predictive models so complex, it is difficult to understand. What is the result? What is the prediction it is giving? It is very difficult to understand. And cost and complexity. Because to do this analysis, we need a lot of skills, a lot of tools, specialized tools, and it is very complex to implement. So you need money to invest on this if you want to get a support predictive analysis. And last is the ethical consideration. So what is this ethical consideration is, it because you particularly deal with discrimination and bias, the organization need to be aware of this consideration where this predictive model should be very fair and unbiased. You cannot be biased or think about something one part only in a company to do a predictive analysis. So these are some of the challenges in this. Though there are some of the challenges, still we are running with the predictive analysis. It is so far, as of now, it is working so good. And there are some best practices also we need to follow for the predictive analysis to overcome this challenge and make it as an advantageous one. So the best predictive analysis practices we can say is define a clear objective. You be very clear what you want to identify from your model. Make sure your data quality is good and make sure you will choose a very correct algorithm and the correct model. And you need to evaluate and refine your model time to time. It's not one time I have trained the data and the model is ready, I can use it. No. Time to time you need to evaluate and refine it. Interpret and communicate results. Whatever prediction is identified, you need to understand it. You need to communicate it to the company properly for the business. And whenever you use any data, because it's huge amount of data, it's not our own data. So business data, personal data, you need to follow the data privacy and security and continuously monitor and update the model. It is very, very important to monitor and update the model. So these are the best practices which we can follow in predictive analysis while you are using the data science, so that you will get such a very clear and accurate prediction, so that you can improve your business, you can develop your financial forecast, you can improve your sales, whatever we use in the business. And at last is the conclusion about the predictive analysis. To conclude it, as I say, it's not used in a very particular area only. It is commonly used in each and every nook and corner. You can use the data science. And though there are many challenges associated with this, the quality, privacy, security, everything. But the benefits of predictive analysis is very high. It has improved the forecasting accuracy. It has avoided the risk in the management. It has more efficient operation. It also increased the profit. So to ensure the success of predictive analysis, the organization should follow the best practices such as defining clear objectives, ensuring the data quality, appropriate algorithm, privacy and security, and monitor and update the model. At last, to conclude it, the predictive analysis is a very important tool that is required in the data science toolkit that can help the organizations to influence, to make more informed and strategic decisions, leading to better business outcomes. So this is just an hint about what I spoke today about the data science. Is just a hint. It's a very huge and vast area. So just how this data science is used in the business for prediction, I have just taken a small area and I have tried my best to reproduce the information to the audience. I believe this information has been useful to you all. And thank you very much for listening to me and giving me this opportunity. Thank you once again.
Thank you, ma'am. It has been a pleasure. We are grateful for the time and effort you took to share your thoughts and experience with us. It has been very useful. You have unfolded the depths of predictive analysis and its role in the field of data science. Thank you for joining us.